Okay, class. Today we are going to start our new topic. This is our course about demonstrate AC and DC principles in electronic circuits. Last time we discussed different types of waveforms, which include sinusoidal waveform, triangular waveform, square waveforms, pulses, triggers, and we categorize them into unidirectional and bidirectional, two big categories of the waveforms. Today we are going to start our second element or second chapter, and in this chapter we will be discussing about some basic electrical laws, for example Ohm's law, Kirchhoff's law, and we will be discussing about how to solve different DC circuits. So this chapter is mostly focused on DC theory and DC circuit problems. So let's start. You will see that most of the things you are already aware of, but for the sake of covering this course, we will be going through a quick revision of them. So this is the first topic. It's about solving DC circuits using Ohm's law. As you know that Ohm's law, it was after the name of the scientist Ohm, and Ohm is also the unit of resistance. So he defined a relationship between three electrical quantities which are mentioned here. One is voltage, one is current, and third one is resistance. So according to him, that current is directly proportional to voltage, meaning if voltage is increased, current is increased. And second relationship, he defined that current is inversely proportional to resistance. That means if resistance is low, current will be high, and if resistance is high, current will be low. So it's opposite, inverse relationship. So in short, the formula we remember in a common form is V is equal to I times R. V for voltage, I is current, R is resistance. Unit of voltage is volt, unit of current is ampere, unit of resistance is ohm. So you know all that. And these three triangles, they are for easy extraction of formula. For example, if you want to find voltage, so the formula will be I times R. To find I, which is circled here, the formula will be V divided by R. To find R, which is circled here, the formula will be V divided by I. So Ohm's law you are already aware of. Now we will just look at a few examples, and then you can go ahead with the practice of some simple DC circuit problems which I have uploaded as a worksheet in your journal. So first example is find the current through a resistor R 2 ohms if the voltage across is 6 volts. It's simple. First one is a very simple example. If the resistance is 2 ohms and the voltage is 6 volts, so you need to find the current to this triangle here. So current is equal to V divided by R. So you simply use this formula, okay, or you can just write the common form of this and you can enter the values. V is 6, I we don't know, we just need to find, and R is 2 ohms, and remaining you know how to solve the equation and you get the answer as 3 amperes. That was pretty quick and easy. So whenever you are dealing with the numerical problems, it is a good practice if you make a list of what you know and what you have to find. So if you do like that, there are chances that you will not do any mistake. So example 2 here is in the circuit below, resistors R1 and R2 are in series. Let's see the circuit here. Yeah, there are two resistors R1, R2. We know this is a simple series circuit connected with a voltage here, voltage source. Though they are in series and have a resistance of 5 ohm and 10 ohm. So R1, see R1 is 5 ohms and R2 is 10 ohms. The voltage across the resistor R1 is equal to 4 volts. So he's telling us what is the specific voltage on resistor R1. We need to find the current passing through the resistor R2 and the voltage across the same resistor. So you need to find the voltage and current in resistor R2, while he gave us voltage on resistance R1 as 4 volts, and we know resistance of both 5 ohms and 10 ohms. So first of all, if you remember that in series circuit the current is same, because whatever current is coming out of the battery, the same current is going in R1 and the same is going in R2 and going back to the battery, because there is no other way for the current to flow. So current is same throughout the circuit. That's a basic rule of a series circuit. So if you find if you find current in this circuit, so it means that current will be same for R1 and R2. So to find the current, you can use again the simple Ohm's law. If you want to find I1, okay, if you find I1, that will be same as I2 because there is no difference. Why we are finding I1? Because we have maximum information about this resistor here, R1. We have its value and we have voltage on this resistor. If you see, 5 ohm is given and the voltage on R1 is 4 volts. So we have both of these information available. So same we will put here and we can find out that the current is 0.8 amperes. The two resistors are in series and therefore same current passes through them. So we can simply write without any calculation that I1 and I2 both are 0.8 amperes. So one part is solved. Find the current passing through resistor R2. Current we have found. Now it's turn to find the voltage across the same resistors, means R2. So now we know how much is the R2 value. It is 10 ohms. And now we know current through resistor R2. It is 0.8 amperes. So we know both the things. So it is easy to find the voltage on R2. So now you can simply use Ohm's law to find voltage V2 across resistor R2. So V2 is equal to I2 times R2. Class, it is important that whenever you write the formula in solving DC problems like this, do not write just simple E is equal to IR, okay? Because specifically you are finding voltage on resistor 2, so we can mention it as V2. To find V2, you have to multiply I2 times R2. So if you specify these prefixes with each one of them subscript, you can call it as subscript. Subscript means a accessory to the main term. The main term is V and number 2 specifies that which voltage you are finding out. You are finding out voltage on resistor 2. So remember always to write formulas like this. And whenever you are solving questions, please show your steps, because steps have marks. If you follow the question step by step, you will not do any mistake. So the mistakes will be eliminated and you will be getting maximum marks showing all the procedure. So simply we know that I2 is 10. Sorry, this I2, sorry, R2 is 10 actually. The resistor R2, it is 10 ohms. And the current is 0.8 amperes, which we just discovered that both the currents, they are 0.8 amperes. So simply multiply these two, you will get the voltage. So that's how you simply solve the basic DC circuit problems. Now the third circuit is a little bit complicated because it is a combination circuit. It's not a simple series circuit and not a simple parallel circuit. It's a combination circuit. Combination means these two resistors are in parallel to each other, while this resistor sitting here, this one, it is in series with the battery, the voltage supply. Okay. In the circuit below, resistor R1 and R2 are in parallel and have resistances of 8 ohms and 4 ohms respectively. R1 is 8, R2 is 4. The current passing through R1 is 0.2. So we know how much current is flowing in R1. Current flowing in R1, you can call it as I1. Find the voltage across resistor R2 and the current passing through the same resistor. So now guys, look at this. He is telling us current in resistor R1, but he is asking us to find voltage in resistor R2. So he is giving us data about R1, but he is asking us something about R2. Why is that? The reason he is asking us to find the voltage across resistor R2 because if you remember that in parallel circuit, if two resistors are in parallel, the voltage on them will be same. For example, if voltage on R1 is 3 volts, the voltage on R2 will also be 3 volts, same, no difference. So if he is giving us data about R1, if we find voltage on R1, it will be the same as voltage on R2. So let's look at the solution. The solution says use the Ohm's law to find the voltage on V1. See, because it's easy to find voltage on V1 because we have more data about it. So simply V1 is equal to I1 times R1, 0.2 times 8. Now what is 0.2? It is the current. See, current passing through the resistor R1 is 0.2. So 0.2 is simply the current and 8 ohms is the R1 value, 8 ohms. Simply multiply and you will find V1 as 1.6 volts. So the voltage across resistor R1 and the voltage across R2 are the same because they are parallel. So we can write simply like this. No need to do any more calculation. So VR1 is equal to VR2 is equal to 1.6 volts. Now we use Ohm's law to find current I2. The second part was to find current in resistance R2. So because we are talking about R2, so we can call the current as I2. Again use Ohm's law. Okay, enter the values and simply find the answer. Okay, so let's see how more questions we have. That's the last example. Then I will stop the recording and assign you some work. Example 4 is the current passing through a resistor in a circuit is 0.01 ampere. So current is 0.01 ampere when the voltage across the same resistor is 5 volts. Okay, when current passes through this resistor, what current passes through this resistor when the voltage across it is 7.5 volts? Okay, so it means he's simply asking us to uh, find out the when we increase the voltage, what happens to the current. That's what his main objective is. Okay, the first situation he just simply told us that in a resistor, remember he did not tell us anything about the resistor, its value, what is the value of resistor, no, nothing. telling us a resistor is there and current is this when the voltage is 5 volts. Okay, so you have at least two things about that. If you have current and voltage, you can simply find the resistor value. Once you have that information, then you can work on the next part of the question, which is if you increase the voltage to 7.5 volt, then how much current will pass? So simply use Ohm's law again to find out the resistor first. So R is equal to V divided by I. So V 5 as given here, 5 volts, and I 0.01 amperes as given here in the first part of the question. So we came to know that the resistor is 500 ohms, and he did not told us anything about the resistor, but we found it. It's 500 ohms. Now we have resistor. We can easily solve the second part. What is the current passing through this resistor when the voltage is 7.5 volts? So we have new voltage and we already know the resistor value. Simply use this formula, Ohm's law, I is equal to V divided by R. So new voltage is 7.5 volts, resistor value is the same, and divide and you find the answer. Okay, now look at the uh, initial current, which was 0.01 when the voltage applied was 5 volts. So when you increase the voltage to 7.5 volts, you can see that the current also increased. 0.0125 is larger than 0.01. So voltage increased, current increased. Alright guys, so I will stop this recording here. We covered only the Ohm's law and the use of Ohm's law in solving these simple DC circuit problems. If you have any questions, you can ask.